Now, one of the common mistakes that people make once they learn the basic differentiation rule, the linearity and also the power rule, is to think that you can handle the products that way too. So, for example, you would think that if you have x squared times x cubed, you differentiate this. 2x squared differentiates to 2x, and x cubed differentiates to 3x squared, right? And therefore the answer is 6x cubed. You would think that this is true, however that's not true. And we can actually see why it's not. This is not true. We know that's not true because we know that x squared times x cubed is really x to the fifth, right? Under the rule of exponents, right? If you have the same base, the powers should add up, right? So you have x to the fifth power. Okay? And therefore, when you differentiate this, 5 should hop front, and you have to subtract 1 off 5, so it's 4. And you can see clearly that this is different from that. Okay? So products do not really have a simple way of differentiating. Okay? In fact, for the products, we have something called the product rule. So let me introduce the product rule. If you have two functions multiplied, this is, you differentiate the first thing times the second, plus first thing times second thing prime. That's called the product rule. Now, why is this true? Again, in order to understand why it's true, it's good to know the proof. Let me give you the proof. Limit h going to 0 of f of, well, prime means you have to replace x by x plus h, so I'm going to replace x by x plus h minus the original function, fx times gx, divided by h. Now this proof is non-trivial, so I would never ask you to produce this proof on your own. But the way to make this proof work is to subtract something and add something. You subtract f of x, g of x plus h, and add f of x, g of x plus h, minus fx gx. Sorry, my letters are so small here, but that's fx gx, okay? See, if I take away this hat and give it back, did I do any harm? No, I didn't, right? Sorry for touching your head, but anyway, other than that, I didn't cause any harm. So I subtracted something and added something. Okay, and then I see that these two have g of x plus h as a common factor, and these two have fx as its common factor. So I'm going to factor them separately. Limit h going to 0 of f of x plus h minus f of x times g of x plus h. That was the common factor of the first two. Plus f of x times g of x plus h minus g of x from the second. And because I'm dividing everything by h, I can just make the first thing over h and the second thing over h. Now look what happens. Isn't this f prime? And what about this? That's g prime, right? And because you're sending h to 0, this will turn into g of x. So after you send h to 0, you get f prime of x times g of x plus f of x g prime of x. That's why this product rule works. Okay? And I know that some people would immediately just turn off their brain or something. I don't know how you can do that, but some people are able to do that. And the moment I say proof, they just don't pay attention, right? But maybe more important than the proof is the following fact, that when I say product rule, it's not like a rule such that it makes things easy if you use it. Like, I mean, there are some rules that's just helpful, makes things easy, right? It's not in that sense. A product rule is like a rule in the sense that if you don't obey it, you get fined and punished and sent into jail or stuff like that. That's what product rule is. I mean, it's not as bad. You just get an F for the math, and that means you probably have to spend another semester in college. But there is definitely some punishment if you don't obey the product rule. Yeah. So if you do things like this, then that's like not obeying the product rule, and you get a wrong answer. Okay? And you'll do horribly on the exam. That's why product rule is so important. Okay, so in order to go back to a question that was asked, let me point out how to handle the following question. Suppose we have like 5x prime. Suppose we have this. Now, if you don't obey the product rule, you would be writing, well, why not just differentiate each individual ones, right? And 5 differentiates to 0. X differentiates to 1. So the answer is 0. So you would think that that's the right one. However, this is wrong because you did not obey the rule. Okay? If you don't obey the product rule, you get it wrong. Okay? That's wrong. Okay? I mean, instead you can use the linearity rule, which says that constants can be pulled out. So one right way to do this will be 5x prime is 5 is a constant multiple, so I pull it out and differentiate the function only, and that gives you 1, and that's equal to 5. Okay? So that's actually the better one in this situation. But if you wanted to use the product rule to see why this is also equal to 5, you have to do the following. 5x prime equals to, the product rule says, if you see a product, differentiate the first one times the second one untouched, plus first one you don't do anything but take the second one and differentiate. Okay. And what's the derivative of 5? It's 0. 5 times, if you differentiate x, it's 1. So 5 times 1 is 5. And 0 times anything is 0. So that's just equal to 5. So you get the same result. Even this one, if you use the product rule appropriately, you get the same answer as this one. So if you apply the product rule, differentiate the first, leave the second, differentiate the second. And this is 2x. This is 3x squared. This one gives you 2x to the 4th power, whereas this one gives you 3x to the 4th power. 2 plus 3 gives you 5. So you do get the same answer